Hello everybody, and once again welcome to Pankaj's Echelon tutorials. And as I told you, I am preparing a series of chemistry revision for the sake of IGCSE students because the exams are under the nose, and I'm going to deal with certain concepts, okay, which maybe the student may find it difficult or they are not unsure about, they are not sure about. So those concepts I'm going to discuss, only the main concepts from the topics. Okay, so this is the continuation of that series, and today I'm going to discuss a topic called preparation of salts, and this is from the chapter acid, base and salts, that is chapter number 3. Okay, so let us get started, and let us get started with what is the meaning of preparation of salts and what it has to do with. Okay, fine. So let us get started. So we are going to deal with something called preparation of salts, and preparation of the salts totally depends upon whether the salt is soluble or insoluble in nature. Okay, that is whether the salt is soluble in water or whether it is insoluble in water. If it is soluble in water, okay, we always write AQ, meaning aqueous. Okay, and if the salt is insoluble, okay, we write solid. The state is represented by S, solid. This means insoluble. Okay, and when we write AQ, it means soluble, right? Okay, so sorry, first let us try to understand which are the salts which come under the category of soluble salts and which are the salts which come under the category of insoluble salts. So all nitrates, basically all nitrates, they are supposed to be soluble, right? So I'll say that all nitrates are soluble in nature, water soluble of course. Sodium, potassium and ammonium salts are also water soluble. All acids are supposed to be soluble in water. Barium chloride, magnesium chloride and calcium chloride, all three are soluble in water, and copper sulfate is also soluble in water. Now let us see what are not soluble in water. Barium carbonate is insoluble, calcium carbonate is again insoluble. Then chlorides, bromides and iodides of silver, they are all insoluble. Lead chloride, lead bromide, lead iodide are again insoluble. Barium sulfate, calcium sulfate, lead sulfate are all insoluble. Copper oxide is insoluble, and all metals are of course insoluble, right? So this is all about what are the substances which are soluble, what are the substances which are insoluble, right? So we will be dividing this preparation of salts into two parts. Okay, preparation of something called soluble salts and preparation of something called insoluble salts. So first I am going to deal with preparation of soluble salts. So basically there are 4 methods for the preparation of these soluble salts, and let me list those names. Okay, so when you take some acid and you react with some metal taken in excess, this is one method. You can always prepare soluble salt with this method. Second method is you will have to take an acid and you will have to take some insoluble carbonate, but that too in excess. So this is a second method which will give you a soluble salt. The third method is you will have to take some acid and you will have to make it react with some insoluble base. Now insoluble base are mostly basic oxide, and this process is known as neutralization. I'll explain you when I deal in detail. And the last method is when an acid is made to react with an alkali. Now alkali are nothing but water soluble base. Okay, so base which are insoluble are not alkali, but there are certain soluble base, water soluble base, those are termed as alkali. So when you are reacting acid with an alkali, that process is known as titration, and this also will result in a soluble salt. Okay, there is a difference between neutralization and titration. Many students, they may not be knowing the exact differentiation between the two, but then today I'm going to discuss that also at the end of the session what is the difference between neutralization and titration, right? So these are the four methods which are basically used for preparation of soluble salts. Now these four methods I'm going to discuss in detail and taking one example of each method to explain you how it works. So starting with the first method, that is reacting acid, okay, with a metal, right? So acid plus a metal, and of course the metal has to be in excess, right? So this is the first method I'm starting with. Okay, so for this method I'll take an example of, say, hydrochloric acid. And hydrochloric acid, as you know, it will be in aqueous state. Okay, so I'm taking hydrochloric acid which is slightly dilute, plus I will take magnesium metal, okay, and this I'll be taking in excess, and the reaction will be something like this. So it should be HCl plus magnesium will give you magnesium chloride, MgCl2, and hydrogen gas will be liberated. Now of course you can see that this is not at all a balanced equation. So to balance it, I'll do something. Okay, I'll put 2 HCl over here, and I think, yeah, now it's balanced. Okay, so this is a balanced equation for this particular reaction. That is the acid, this is your acid, and this is your metal. Okay, I'm writing M for metal, right? And this is, you have to take in excess. Now why you have to take this metal in excess? Because you have to ascertain that all the acid that you have taken in this reaction, is getting used up. Okay, so you should not have any unused acid remaining at the end of the reaction, right? Which is not healthy, right? So the acid has to be completely consumed. It has to be used up. Okay, in other words, you can say that the acid HCl has to be your limiting reactant, and the magnesium metal has to be in excess. Okay, in other words, if you say once the reaction is over, you will have still some magnesium left over to be reacted with HCl. Okay, but HCl will be totally consumed, right? Okay, magnesium being a metal, I'll write a S for that state. Okay, and magnesium chloride is the salt that will be formed in this process, and since this is a soluble salt, I'm going to write AQ over here. Hydrogen being gas, I'm going to write G. This states of the substances, okay, or the compounds, is very important. You have to mention in the reaction what is the state of a particular compound in the chemical reaction. Fine. So this is a chemical equation that represents how an acid and a metal reacts to give you a salt. Now this is that salt which is soluble salt. Okay, so this is the first example. Now I'm going to explain you how you have to prepare this particular soluble salt, that is magnesium chloride. Okay, now what you have to do is to prepare this, the metal that you are going to take, okay, acid can be mostly hydrochloric acid, okay, and the metal that you will be taking can be either magnesium, or it can be aluminium, or it can be zinc, or it can be iron, or it can be tin. So remember this word MAZIT, mazit. Mazit is telling you all the metals that you can use for this particular purpose, that is preparing soluble salt. Okay, so M stands for magnesium, I'm writing here. A stands for aluminium, Z stands for zinc, I stands for iron, and T stands for tin. So these are the elements, these are the metals which you can always take or you can consider for this particular reaction. No other metal you can consider for this reaction. Okay, fine. Now what you have to do is, in this particular experiment, typically you will have to take excess of magnesium. So take more amount of magnesium and add some small amount of dilute hydrochloric acid to that magnesium. What will happen? A reaction will start between the two. An effervescence will be seen. That effervescence is due to the hydrogen gas which is evolved in the reaction. Okay, and a clear solution of magnesium chloride will be produced. Okay, so what actually happens, mechanism of this reaction is such that the metal, that is magnesium, okay, will lose, magnesium will lose, okay, electron, because metals, you know, they have the tendency of losing electrons. So magnesium having 2 electrons in the outermost orbit, it will lose those electrons. Okay, and these electrons will be transferred, okay, or it will be taken away by the hydrogen ion. Okay, this electron will be taken by the hydrogen ion. Okay, this electron will be taken by hydrogen ion, and hydrogen will be converted into hydrogen gas. Okay, so 2 ions of hydrogen will take 2 electrons. Okay, magnesium will give you 2 electrons. Okay, I'm talking about one atom. One atom of magnesium will give you 2 electrons, and those 2 electrons will be taken by 2 hydrogen ions to get converted into hydrogen gas. This is how hydrogen gas is produced. Now, if you are wondering where this hydrogen ion has come from, okay, so well, this hydrogen ion has come from the acid in the reaction. You see, we have taken HCl. So HCl will get dissociated into H plus and Cl minus. This is where from where the hydrogen ion has come. So hydrogen ion is coming from the hydrochloric acid. It is accepting electron which are coming from the magnesium, and that hydrogen ion is getting converted into hydrogen gas. Fine. Then you are left with this chloride ion, and you are left with the magnesium ion. Okay, so when magnesium will give away 2 electrons, again this magnesium ions will be formed, isn't it? So these 2 magnesium ions and the chloride ion, they will combine to form MgCl2, the insoluble salt that we wanted. This is the mechanism. Now what will happen when the reaction takes place? Effervescence is seen, hydrogen gas is evolved, and what you'll have to do is, after some time, you'll have to filter this particular solution, because there will be still magnesium left, because remember we had taken magnesium in excess. So magnesium is going to remain in the solution. Okay, and because magnesium is solid, we can filter off. So using a filtration apparatus, okay, you can always collect in a beaker the filtrate. Now this filtrate, filtrate, this filtrate is nothing but magnesium chloride solution, right? Magnesium chloride solution. And in the filter paper, on the filter paper here, you will be collecting the solid magnesium which was in excess, right? So the excess magnesium has been removed from the solution, and you have a filtrate, or you have a clear solution of magnesium chloride. Now this particular filtrate which you obtain after filtration, okay, this filtrate consists of magnesium chloride solution. So the next step is you'll have to do crystallization of this magnesium chloride solution, right? Now what is crystallization? In crystallization, you first either heat the solution, okay, on a very slow or a very faint flame, or you make it happen by evaporation only. Okay, no need of using any flame. So either you do it by evaporation, or you heat it at a very a very reduced flame. Okay, so when you heat, what will happen? The magnesium chloride crystal formation will be starting. Okay, and a stage will come when the crystallization will just start taking place. Crystallization is the MgCl2 salt crystals will start coming out. Okay, that is known as the crystallization has started. Now how will come to know that crystallization has started? After heating or after making this particular MgCl2 solution evaporate for some time, you dip a glass rod into that solution. Okay, just dip a glass rod into that magnesium chloride solution, right? Now, if you see that on the glass rod certain crystals have started accumulating, okay, if you find some crystals settled on the glass rod, that means the crystallization has already started. At that stage, you have to stop heating if you were heating, and you have to remove from that place. If you had kept for evaporation, you remove from that place and keep in a cool atmosphere for cooling down. Okay, so you can shift the place and take this to some other place where you have kept it for cooling. Now when this particular cooling is happening, what happens? Crystal starts forming. Okay, and as it goes on cooling, more and more crystals are coming up into the beaker, right? Once the crystals have formed totally, okay, all the crystals have been formed, then what you have to do, you have to take those crystals, you have to just wash them with water. Okay, so just, pour a little water over it, and then you place between the filter paper, okay, and just make it dry. Okay, this is known as something called drying and purification of the crystal. Okay, so once the crystals are obtained after cooling, you have to wash it with water and you have to dry it by placing those crystals between the filter papers, and you have to slightly press it. So all the remaining water will be absorbed by the filter paper and you will get pure crystals of magnesium chloride. So this is how magnesium chloride salt, which is soluble, can be obtained by this first method, right? So after dealing with this first method, let me start with the second method. Now second method states that it should be, now what is the second method I have considered? Okay, let me go back. The second method is acid and insoluble carbonate. Okay, so this is the second method, acid plus an insoluble carbonate. Okay, now here in this method, I am going to take an example of say nitric acid. Okay, and the carbonate that I want to take is copper carbonate. Okay, so I'm going to take copper carbonate, CuCO3. Now this in fact is copper 2 carbonate, right? This is copper 2 carbonate, or it is also known as cupric carbonate, right? So copper carbonate, now this copper carbonate being insoluble, I'm going to take it and write it as a solid because it is insoluble, right? This I'm going to make react with the acid, and this time the acid that I'm going to take is nitric acid, HNO3. Okay, this is the acid. Now these two are going to react and we are going to get copper nitrate, CuNO3 twice. Okay, and I'm going to get carbon dioxide, and I'm going to get water. Okay, so remember, carbonates, they will give you the product as carbon dioxide and water. Okay, so this is that reaction, and I hope it's a balanced equation. Let me check, and no, it's not balanced. So if I put 2 over here, and now it seems to be balanced. Okay, fine, now it is totally balanced, right? Okay, so this is that reaction. Now here again, what you have to take care is this carbonate, metal carbonate, okay, now being insoluble, right, it is in a solid state. So first what you have to do is you will have to take excess of carbonate, and then you will have to add nitric acid. You'll have to take excess of carbonate, copper carbonate in a beaker, and you have to add uh, nitric acid to it. Okay. Now what you are going to take in excess is the carbonate, right? So you are going to take more quantity of copper carbonate, and to that you are going to add nitric acid. Now when you are doing that, okay, slowly gas will be evolved, that will be carbon dioxide gas, and copper nitrate, CuNO3 twice, will be formed. Now this is the soluble salt that you are getting. Okay, copper nitrate. Again, the same process you will have to, because there is excess of this copper carbonate. Okay, so after the reaction, what will happen? The HNO3 will be used up completely because that is limited in quantity. It's a limited reactant. So it will get used up totally, but this copper carbonate will be in excess. So after the reaction is over, you will have to get rid of this excess of copper carbonate, okay, by filtration, because it is solid, it is not soluble. It will be remaining on the filter paper, and the filtrate will be containing this particular soluble salt solution, that is copper nitrate solution. Okay, this solution. Now again, this solution will be, you will be getting in the form of a filtrate, which, as I told you in the previous method, you will have to keep it for crystallization, and after crystallization, the pure crystals of copper nitrate can be obtained, and they can be washed and dried same way as I explained you in the previous method. Okay, so this is a way of obtaining a soluble salt called copper nitrate using insoluble carbonate and an acid. That was the second method that I discussed with you. The third and the fourth method I'll be discussing with you in the next session, because those two methods, the third and the fourth method, are based on neutralization and titration. And in these two methods, I want to explain you even the difference between neutralization and titration. And in that session, in the next session, I'll wind up with this preparation of salts, preparation of insoluble salts. Perhaps I may also take up the topic of preparation of insoluble salt in that video itself, because it's a small topic, right? So that's all for today. See you. Bye. Take care, all of you.